Hey everyone, welcome back to Deterministic, where today I continue my quest for practical ways to embrace determinism and take control of the chaos in our code. In episode 1, I introduced the Nest.js stack and some of my tools and style decisions while working with it. It's essentially my lightning talk for why you would want to build on a stack like this, and if you haven't checked it out, take a look. I also wear this same shirt in a move of unintentional coordination that worked out pretty well. Like I said in that episode, Nest gives you a framework with a lot of extension points and test helpers, mostly enabled through the dependency injection system, which itself can be a little tricky to work with, but the functionality that it brings is well worth it. It has first-class support for TypeScript and a whole lot of community plugins, and I like to use the NX build tool to bootstrap and manage my Nest.js apps. If you've ever used the Yeoman tool from classic NPM ecosystems, it's a generator that allows you to bootstrap an entire application or different pieces of your application based on templates and input that it'll ask. And NX mirrors that functionality with its generators and templates so that you can build an app from scratch or add a new controller to an app or something like that. I'll take a few moments to talk through how to bootstrap a Nest.js app with NX from scratch, talking through a couple of the customizations that I like to make when working with it. But then I'll pretty quickly move on to the full application structure that I like to work with, how I lay out my resolvers and controllers, how I set up my data access layer and the services that act as the go-between to work with them. So we'll talk through a real production application stack pretty quickly, but first, let's talk through creating that NX app from scratch. Alright, so I've got the README for my example project pulled up here, but let's cast it aside for a moment and talk about creating a new application from scratch. So I'm going to use the npx utility, which is the Node community's way to run scripts from npm without actually installing things to a project, to a package JSON file, or globally. So I'm going to use create NX workspace, and I'm going to give it the preset nest, and I'm going to tell it to use the organization name or the project name or the repo name, whatever you want to call it, of example. So it's going to make sure everything is current for my checkout of create NX workspace, and then it's going to ask me another question. So this is in addition to what I already told it. My repo is example, so now it's asking for the application name. This is the primary entry point for your application, the first folder in the apps folder for NX. So I'm going to also call it example. I'm going to say no thank you to NX Cloud. It sounds cool, but not today. And then it's going to run through an installation with npm and get everything set up for you. So once it's all checked out, I like to customize a couple of things. I like to change a couple of things up. So let me freeze time for a moment so that you don't have to wait through it. All right, welcome to the future. The install is done. Everything is set up and ready now. So I'm going to go ahead and add a couple of more additional dependencies that I like. I'm working with GraphQL here, so I'll add the Nest.js GraphQL library. I'll add Prisma, the ORM I mentioned in the last episode, and also up there I added Passport, which is a popular authentication library with a lot of different plugins for different things. So that installed pretty quickly. Let's go ahead and pop open the code window so that we can see the structure that it builds by default. So you've got your apps folder, which just has example right now, which is that entry point that I talked about. Then you also have libs, which is just a placeholder right now, but this is where all of your libs you'll use like internal packages will live. And then it sets up some general things here. Workspace.json is an important file in NX projects, but right now it just has everything at the bare minimum defaults. Package JSON looks like you would expect it to, but it builds a couple of NX commands into it. The tsconfig is where some of the magic happens. This is where it will configure your libs. Once you generate libs using the nxgen commands, they'll be automatically added to this tsconfig and automatically added to your workspace and everything, which is really handy. For Nest.js, it sets up kind of an initial structure here. An NX convention is to have node projects bootstrapped with a source/main.ts file. So the Nest plugin follows that convention, and you have your bootstrap function here. That pulls in your app module, and modules are the top-level way of packaging things in the Nest dependency injection system together. This is going to give you a lot of convenience around bootstrapping things for running in production or test helpers or just all kinds of different situations. And then it gives you a default or kind of a stubbed out controller here, which is pretty basic. It doesn't give you a whole lot there. And then the service structure, like I was talking about, all of this is well and good. I think the one big thing that I like to change is I like to take .spec and call it .test instead. So everywhere I'll see that in here. Let's go ahead and just do a find in folder and just change spec to test everywhere. So here we have it in the jest config. So this is the file that it's pointing to. I'll change that to spec. I'm going to change this, this to test. I'm going to change this one to test. And then once more right in here, test. And so that's just the way that I've always used jest, is with .test.json, and so .spec or .test.ts, and so .spec just looks really odd to my eyes. I think it's more familiar in the Angular community though, which makes sense because that's where NX kind of emerged from. So that's one of the things that I will typically do. I also tend to customize the ESLint and add some additional things in. I'll show off my ESLint. In fact, let me pull up the example project now. The ESLint there has some extra rules, some things like the TypeScript recommended rules from Microsoft and NX, some stuff from Prettier. There's my super controversial no barrel index rule there. So you'll see I'll set it up with my own personal flavor. That's going to vary from project to project depending on the team that you're working with. But let's go back to the example project now. Let's look at a real world example with the Caster project that I have out on GitHub. I've got a real world example with controllers and resolvers wiring into services that speak to the data access layer through tools like Prisma to talk to Postgres databases or whatever data sources that you have out there. I've got Redis for some real-time events built in here. I've got the README pulled up. I won't go through the steps line by line on how to set it up here because I think the README explains it pretty well. But this is how I'll structure my real-world production applications. So the first piece of this architecture that I'll talk about is the data access layer, the database entries that I define through Prisma. Prisma is an object relational mapper. That means it takes a SQL relational data structure like what you get with Postgres, and it translates that to objects and nested objects like we're used to working with in an environment like JavaScript or Node. And the way that it does that is through an approach inspired a lot by GraphQL and the code first, or I'm sorry, the schema first approach, where you define your schema and then generate a lot of boilerplate code and lots of signatures and things like that based off of that schema as the central source of truth. So Prisma does the same thing for your database with its schema.prisma files and its own schema definition language for SQL databases. And it's got a couple of implementation details up here at the top, but then you see a language for defining your models for, I use ULIDs, which are universally lexically sortable IDs. Instead of UUIDs, it generates IDs that are sortable but aren't guessable. You can't guess the next iteration in a ULID. So I love it for that. I've also got my automated created add and updated fields. And you see fields like this, fields like profile. This is defining a relationship. This means that the profile attribute relates to the profile model. And since there's a question mark at the end, that means it's optional. And so you'll see the reverse relationship here Profile is related to user here, so that's also optional with a question mark, and it defines the relationship with a directive here, kind of similar to what you would see in a GraphQL schema file. So I've got my data laid out here in the schema.prisma, and so what it'll do is it'll generate a set of migrations for me. And so my first migration was just introducing ULIDs themselves. Thank you, Postgres, go away. So this is the code mainly copied from the GitHub repository that I've called out here for PGULIDs. To get those set up, and then I went ahead and created each of my migrations separately. So I added each model separately to the schema.prisma and then generated each one of these. And the neat part is that Prisma allows you to customize these. So you might define a model in your schema, but then you might want to customize the relationship name or the index name, or you might want to add some additional constraints or some check constraints or things like that. You'll see I do some fancy things with functions in my roles and permissions triggers library to kind of make sure that my generic relationship that I have set up with roles and permissions are a little bit more strictly enforced than you would normally see in a setup like this. But basically, it allows you to do whatever you want to with the SQL based on the base, the foundation that it generates for you, all using that schema.prisma as a source of truth. And so it'll also occasionally, when you're updating versions of Prisma, it'll add new features and things through an automatic migration because it knows the schema and can calculate things before and after based on the introspection that it's doing in the database. It's a pretty nifty tool. I like it. It's got a lot of features for migrating and managing your data smoothly. But then also the other piece of what it does is behind the scenes in this node modules directory here, you're installing @Prisma, but then it also generates this .Prisma folder inside your node modules. And so this .Prisma is all of the generated code, all of the meticulous, intricate, related data, and the fields that you can select, and just a wealth of boilerplate code that you don't have to write yourself on accessing your database in a type-safe way that also gives Prisma everything that it needs to generate efficient joins and things like that. They're actually using GraphQL behind the scenes, which is awesome. So I love the way that Prisma sets things up. You have to do a little bit of work to package things correctly because you'll see it's generating query engines. These are Rust-based binaries that they're building for different platforms. And so when you build a Lambda package, for example, you're only going to want one of these engines. And so you've got to structure your packaging so that it excludes what you don't need. But that's minor. Once you set that up once, it's generally good for the rest of your time there. Another thing that I do with Lambda functions specifically is I package Prisma as a layer, and I update that layer independently because it can be a little bit chunky. And in a Lambda situation, layers are a lot more efficient because they're read-only access layers that don't count towards the space that your Lambda function itself takes up. I love it. The way that you use Prisma, all the generated stuff, let me find, oh yes, that's going to be in my libs. Let's take a look at my shows lib. Shows manages the shows and episodes entities. And then I have a shows service here. Now, I'll talk more about how all these pieces fit together, but this shows service behind the scenes uses Prisma to actually run SQL queries. And so here's this .Prisma is the generated client that Prisma is creating. Show is actually a reference to that table in the database. And then find many is an operation that I want to perform against that table. I want to find everything based on all of these inputs that I give it for a get many, or get itself is much simpler. I just find the first one that matches that ID. You can tell it what related entities that you want to include with it. I think shows doesn't have that, but other models will have include statements saying that you want to include a nested related model and how deep you want that to go. So it's got a lot of tools for working with your data in a really convenient way with lots of autocomplete and things like that to make it nice to work with. And yeah, I use a tool called Prisma where is it? Nest.js Prisma. That's a library that I use to manage the Prisma instance itself at the top level. And the reason for that is that Prisma sets up a connection pool automatically. So each instance sets up a pool of connections, not just one connection. And so if you have multiple instances, you might end up with, 50 different connections with across 10 different pools or something like that you weren't really intending, and you can run into max connection issues and things like that. So be careful about that and use something like Nest.js Prisma, or learn from how it injects things at the global layer. My app module, yes. So this is where I'm actually pulling in Prisma module, which is one of the things that are provided by Nest.js Prisma. In Nest.js, the app module is generally the top level module that you want to initialize when you're bootstrapping your application out in a container or in a Lambda function or something like that. This is going to pull in all of the different pieces and establish some of the top level dependencies like Prisma that you share across the whole application. And so that's, you see I'm designating it is global is true. So that means anywhere we're pulling in Prisma, it's going to use this instance, and it's going to be a singleton essentially across it. And then I've got some options here that I'm setting up. You can see I'm setting up some other things too. I'm setting up the GraphQL module. Where's that? From Nest.js GraphQL. And so here I'm setting up an auto schema file. So this is where it saves the generated schema.graphql. I'll talk in a moment about schema first versus code first, and I'm using the code first approach here. And then I've got a couple of other things that I'm setting up. The events module is my real-time WebSocket events that I'm trying to kick off at the top level and listen. My auth-z module is my authorization rules that I implement via a library called Castle, and this pulls in the different rules from pieces in a decoupled way, so I can split this across multiple entry point applications if I want to. And same thing for roles. This spreads in all the roles and permissions that we'll be using in this version of the application. And then I've got individual modules for the libs that I have. So I like to structure my libs around domains, so not necessarily entities. So like the user's lib over here manages both the user's entity and the profile's entity. And that's because they're coupled. They're tightly related. You can't really have one without the other. And same goes for my shows lib. I've got shows and episodes that I'm managing within the same library. That's because they are closely related entities, and there's no reason to separate them into their own libs. And then I have some utility things like my auth-in lib here. My auth-in lib uses the built-in Nest.js passport stuff that I was talking about to set up guards to attach context like the JWT payload to your request object so that you can make use of those inside your methods and things like that. And so this is how I generally set up my Nest.js application structure, and Prisma gets pulled in at that top layer. So my main.ts, like I was saying, main is a convention in the NX community. My main has an init and bootstrap function that's a little more complex than the one they generate by default. And it pulls in that app module and initializes it and gets it ready to listen for new HTTP connections. You will see in the workspace.json, which my workspace is quite a bit bigger than the default one that gets generated. I have some functions down here for migrate, db migrate, db deploy, which is a pipeline version of migrate, reset for when you want to blow away your database locally. I've also got some Docker commands here. Whoops, I hit the wrong button. Where'd it go? There it is. I got some Docker commands down here that really just use yarn to bring Docker up or Docker down. This is based on the Docker files that you find inside the apps. So I've got app, here it is, Docker file here. And then, the Docker Compose file is actually the main thing. Docker Compose pulls in Postgres and Redis as my supporting processes that it spins up in a Compose formation locally. And then I've also got a Docker Compose app for when you want to test the Docker image of the app that you're building, which is not often, but sometimes to troubleshoot build issues, you want to do that. So I've got it separated. But back to the actual migration step. This is using npx Prisma and just calling migrate or calling deploy. Yeah, and I think the main things here actually call out to NX to work. So yeah, that's how I have all the database access set up. All right, so next up, let's talk about the GraphQL structure. Let's talk about how NX provides a set of decorators that are really similar to what you would see for their REST controllers, but they are called resolver and query and mutation. These decorators annotate all of your classes and your methods in a way that Nest can discover and pull together at runtime to stitch a complete schema with all of the resolvers and everything, and attach middleware to different layers of it. So what I'm talking about here, let's pull up one of our libs. Let's go with a simpler one. Let's go with shows. So shows is going to have a resolver. And so this shows resolver pulls in the resolver decorator. And this decorator comes from the Nest.js GraphQL library. And the decorator is something that's relatively new to JavaScript. You've seen it in other coding communities. If you've ever worked with things like Python or especially Java with all the Spring annotations and things like that, it's kind of a similar concept. We're taking the shows resolver class here and we're wrapping it in this decorator that tells Nest, hey, this is a GraphQL resolver. Here's another one to initialize when you load. And it tells it what model, this is a class that I will pull up in a moment to show how you build up GraphQL schemas in the code first approach, but it shows what model this resolver takes care of. And then I'm also wrapping it in some guards to add JWT context and to add some authorization abilities here, which I'll talk about in a little bit. This is the code first approach. So there are two common ways to build up a GraphQL schema. You've typically got your schema first approach, which looks really similar to the Prisma stuff that we were looking at a moment ago, where you'll have a schema.graphql or a collection of schema.graphql files spread across your application that then get pulled in by something like GraphQL code generator that generates a lot of your type signatures and your model types and things like that. It's really convenient for small teams and prototypes and things like that. You implement your server-side resolvers by taking the generated resolver types and creating implementations that unify with the type signatures for each operation. But in larger team settings, the feedback that I've heard most often is that it's unwieldy in larger teams, and it can be hard with generating merge conflicts and things like that based on all of the code generation that comes from that schema. Once your surface area gets really large, what I've heard is that the code first approach is much more maintainable, and you can bring in tools from your language ecosystem to help you manage some of the chaos that might be a little harder to do with the schema first approach. The idea is that schema first requires a whole lot of extra schema first specific tooling, whereas the code first approach allows you to use the tooling you're already comfortable with in your language ecosystem, TypeScript or Java or what have you, and builds the schema based on that. So your code is the source of truth. So that's the approach that I'm using in my project here, code first GraphQL, where I'm defining my classes, I'm defining my methods, I'm defining the arguments for my methods and the input types that they're using. All of that I'm defining in the code, managing it with TypeScript, and then Nest.js generates a schema.graphql file based on that. So you can see down here, this is an automatically generated schema.graphql file based on all of the annotations, the decorations around my classes and my methods and signatures and models and DTOs and input types and all of that kind of stuff. It actually does work together to be pretty maintainable, especially when you've got a well-tuned TypeScript stack, I think. So One of the things that I was mentioning that it uses are these model classes. So there are two different classes that you can define that will generate additional types beyond just your queries and mutations in your GraphQL schema. The first one is this object type, which maps to the object type from the GraphQL schema definition language. And you wrap it with this field decorator to tell it, hey, this property is a field and it resolves to this kind of type. There are, specifically with this top level object type, you have to do a little bit, you have to jump through some hoops to add null as another possibility here. So in this case, since this one up here, technically, I don't think we need this string definition because we're not using a null. It can automatically detect that, hey, this title is a string based on the type that the property itself is. But then when you have string or null, this, or optional especially, this reads as a union of string or undefined or null, which is not easily represented in the GraphQL schema definition language. And so you've got to tell it, no, actually this is a string and it's a nullable string. And so that tells it it could be undefined or null based on, or actually in the TypeScript, it could be undefined or null. In the GraphQL schema definition language, there's no differentiation between undefined or null, which gets tricky. But with your input types, so like here's my input type for create show input, update show input. A recent change to Prisma actually made this a lot easier to manage. You don't have to do the crazy null things that I was doing. So you can see my title, I'm not specifically passing in the type. And then my nullable fields, I'm just passing in the fact that they're nullable, unless it's a custom type like this content field here. This content field is a JSON-B field in Postgres language. And so here I'm saying, okay, let's use this GraphQL type JSON, which is a scalar that comes in through NPM. It's actually a library of that people have shared for validating, nested, unpredictable JSON input. And then internally, I'm giving it this Prisma.input JSON value because that's what Prisma sees it. And the goal here is to unify our GraphQL input type with our Prisma input type so that the input is interchangeable and we can pass it back and forth pretty easily when we're handing things from our controllers or our resolvers into our services that are actually making the SQL queries through Prisma and everything. So that's why you'll see some that are set up a little bit tricky like this. Let's see, yeah, here's one that resolves to a related thing, a show. And so it's actually pulling in the show class and saying, hey, field, this resolves to a show. Oh, yes, and it's nullable. So all of those work together with the resolver classes themselves and the methods on the resolver classes that define GraphQL operations, which can be queries or mutations. And it reads all that in at runtime and generates that schema.json or schema.graphql file that you see there. And then I still use GraphQL code generator. It's an incredible tool. In my case, I use it to generate a bunch of boilerplate types for testing, mostly in this case, but you can also use it to generate things for the front end. You can generate Urkel GraphQL client hooks. You can generate a JSON or a JavaScript client for GraphQL, all kinds of different fancy things that you can do with GraphQL code generator. Definitely check it out, even in a code-first environment. It's very handy. So each of the methods that you see here is a GraphQL operation, like I said, and they're decorated with a decorator of query or mutation. So a query is a read that doesn't change data, it doesn't mutate things. And a mutation is an operation that does change something. It could be deleting something. It could be updating something. It could be modifying a relationship. Anything that's destructive or not read-only is marked as a mutation. And it's a helpful distinction. It helps you think about your data more deliberately and the things that you can do with it. Similarly to how the object types and the input types work, the decorators will take the type that it resolves to. So in this case, the getShow method, that maps to the getShow operation in the GraphQL schema. And so the getShow operation will take an input with one property ID, and that ID is going to be a string, or in GraphQL language, it's known as an ID, which denotes a special string that's an identifier. And then it takes it and calls the service with it. So it's got the ID, it's doing a whole bunch on the Nest.js layer to validate the input and make sure everything is correct. And then it's calling the service with the ID to get the show object back. The show could be null, and so I say, all right, if it's a show, return the show, otherwise return nothing. So that's how I turn show or null into show or undefined, which matches what the GraphQL schema expects. I'm getting a little more sophisticated down here with my get many shows. I've got my show condition, which again, these are classes that define input types that we're using, that the Nest build process is aware of, so it knows how to build up the schema and knows how to validate the input that is being sent to it. So you can even model things like enums. What is it? Register enum type is a little helper to make the enums easier to work with. But I've got some helpers here especially for get many. Get many can be a tricky thing, especially with pagination. So I've got some helpers to make pagination easier. And it actually returns a shows page, which is a structure that has a data array, and it has then some metadata about what's being returned. You'll see some extra little pieces like request user and ability. These are some of the middleware pieces that I talked about. In this case, wrapping particular parameters that are being used in the method signature, and basically injecting properties as your inputs in your method. So like the first argument here is going to be the actual create show input that's already been validated through Nest.js and is correct. And then you have this is a request user. This is a decorator that gets the actual user with profile object off of the request itself based on the JWT token. That's one of the things that the authz guard is adding to the request. You'll find things like guards often enhance the request with additional detail that you can then pull out and use with these param decorators like this. And so ability is another one of those things. That's the castle authorization scheme that I was talking about that I'll introduce later on. But basically, the body of the resolver is where you take the incoming request and translate it to the generic terms that the service speaks with. So the service is going to be your internal business logic. The service is going to be the layer that actually speaks to the data access like Prisma and things like that. And the service, generally the way that I like to organize it is that the service always operates knowing that it is fully authorized, and it doesn't have to worry about things like HTTP or headers or parameters or query strings or any of the things that make it an HTTP request, because I want to also be able to use it with a WebSocket event or an event bus event, or any number of other ways that your service may be triggered that might not speak HTTP. It might have nothing to do with REST or headers or things like that. It might be totally different. And so the service speaks in TypeScript, and then the controllers and resolvers take the incoming request and translate it to the more generic TypeScript language that we're using to manage our business logic. So you'll see the show service really is just using Prisma. At this point, the only business logic that we've really got wrapped around it is accessing the data. But I think the service is the right place to do this. And you see I've got tools for paginating and things like that here in the service. And it's using the Nest.js structure to inject the Prisma service there in the injector, so that this.prisma.show, like I was showing off before, actually refers to the right thing. And so what it uses to pull all that together, to pull this resolver and this service together, is the module. I said before the module was the dependency injection packaging tool. So whenever I want to use shows, I can pull in the shows module, and that will make sure that the shows register or shows resolver is registered. Because that uses decorators, it's not something that you have to explicitly import anywhere. Those decorators leave a metadata trail that Nest.js knows how to follow to find all the resolvers. So as long as it's provided, as long as it's in the providers array here, it'll pick up the resolvers when you're trying to use GraphQL. But the other part of it, the service, is not that way. The service is something that you have to explicitly inject to wherever you want to use it. And so I add that to my exports here so that it's available to other modules that import this module. They can then use the shows service as if they were providing the shows service, even though this module is what's providing it. It's a convenient way to wrap things up. And overall, the goal with dependency injection is to make it so that you don't have to do all these crazy bending over backwards for mocking and rewiring imports and swapping out things at import time. This gives you a way to control it at runtime, so you can mock things in several different ways, all within the same test suite, because it's all being controlled at runtime through the dependency injection, and the modules are how that all comes together. All right, so that is the main kind of structure around how I organize my applications to make them predictable, to make them easy to follow, to make them easy to understand where to look for to find what. I like organizing things in a convention-driven way like this. So once you learn the conventions, then you generally know where to find things when you're in big teams. Yeah. And by the way, if you are deploying this to a Lambda environment or a serverless environment, that top level app module is probably not going to be the way that you go. When you have multiple entry points that you're spreading out really granularly, often you will want to just pull in what you're using for this particular entry point. And so instead of app module, you might have a module for each entry point. And your main.ts, you might have several different main.ts's in different NX apps that define separate app modules that only pull in what you need for this particular entry point. And so that's one of the great things about NX. I feel like it gives you a really easy way to structure something like that. Your entry points are just ways for you to remix all of the tools that you're giving yourself in your libs. And I love the way that it works out. All right, so I think I've covered enough for one night. I think we can call it quits for here. You see how I generally set up my application, how I work with GraphQL in the Nest.js structure. Coming up next, I'm going to talk about using JWT tokens for authentication and authorization, dive a little bit deeper into the guards like I was talking about. We'll talk about integrating with application-specific roles and permissions that you store in your own database, but then define rules with Castle to interact with. I'll talk about writing unit and integration tests to validate your functionality and keep things well tested and well controlled. And I'll also introduce Socket.io for WebSocket real-time events, which are becoming more and more important as our web pages become web applications and expand out to more broad functionality. And then to finish up, I will deploy to AWS, most likely using their Kubernetes stack, EKS, with containers. I've already got a nice GitHub Actions build structure set up, and so I'll talk about wiring everything in that way. And I hope you'll stick around and see what's to come next. After all of this, I'm going to start pivoting to my future stack. I'm going to start talking about things like Rust and other possible stacks that we could go to in the future, things that may not be fully ready for prime time yet, but maybe are really close, and maybe it's worth considering if you need more determinism, if you need more security, if you need to be able to guarantee that runtime errors won't happen. So check back later and find out more, and thank you for joining me. I hope to see you on the next video.